I'm Gazi Abdur Rakib, a PhD student at the University of Utah. Today we will talk about efficient regression scan statistics for detecting anomalies in ALMA data. ALMA produces nearly 39,000 bandpass calibration spectra. About 6% of them contain a platforming anomaly. This anomaly interval you can see here caused by correlator misalignment. If missed, it corrupts the final science data. Human data reducers catch these, but expert crafted heuristics with about a 5% miss rate that doesn't scale with time. We have a dataset of about 38,881 spectrum, among which about 231 of them are confirmed uh, platforming cases. So our approach is to scan every candidate interval, fit separate models inside and outside, and score how much the split improves the fit. Classical methods use a constant mean, but ALMA spectra have a smooth, non-stationary background, so we need a richer regression model. We use Nadaraya-Watson kernel regression. The score is 1 minus the split SSE divided by the global split. With truncated kernels, each window update touches only an order of R points, giving us an order of NWR runtime, about 10,000 times faster than the naive ones. We ablated the score and the IOU of the actual and predicted windows and found that the NWKR scan statistic method outperform all the other methods in precision, recall, and F1 score. We have selected a score threshold of 0.3 and a IOU threshold of 0.75. That is, any predicted window having a score greater than 0.3 and a IOU score of 0.75 is considered as true positive. Here you can see from the graphs that our methods, the NWKR Gaussian and Laplace is outperforming all the other uh, methods. So in a sample data set containing all the 2,231 positive samples and 269 negative ones, NWKR Gaussian and Laplace outperforms far better, achieving F1 score of greater than 0.95, while other methods struggle to reach an F1 score of 0.65. Here are some of actual high scoring detections versus low scoring ones. The blue is the spectra, the purple is the global fit, the red is the local fit, and you can see that the NWKR scan statistic method localizes the platforming anomaly with high scores, while any row having no platforming anomaly scores very low. On the full data set, putting it all together, you can see using NWKR Gaussian, we get a perfect recall of 1, precision of 0.547, and an F1 score of 0.707. The false positive rate is just 0.49 and the false negative rate is 1.3%, and the medium runtime is about 45 milliseconds per signal, fast enough for real-time pipeline integration. This project is funded and supported by Cosmic AI through NSF and the Simons Foundation. Thank you.